Hey everybody, welcome to today's Getting Started with Kubernetes and Rancher online training. I have a lot of people joining the line. So while people are just arriving, I want to let you all know that this session is being recorded. You will get the recording, the slides, and the Q&A after the session. And we have a lot to go over, so I'm going to go ahead and get us started, jump right in. So we have about 90 minutes together. To go over a lot of stuff. We really want to give you a solid technical introduction to Kubernetes using Rancher. We love this technology. This is our bread and butter. We do every day. So we're really excited to give you, the fundamental concept of what you need to really achieve success with your Kubernetes workloads and your containerized applications. We have slides to go through to help explain our material, but we will be demo heavy. We want to show you hands-on how this stuff works. So there'll be a lot of demo. And we try to have this be as responsive to your needs as possible. So please put your questions into the chat as soon as you think of them. And that way we can sort of tailor our presentation as we go. We'll have some specific moments where we'll pause and take questions and try to integrate them into the demo. In order to ask questions, go ahead and put them into the chat in the GoToWebinar control panel. And then finally, we hope this is, if you are new to Kubernetes, if you're new to Rancher, we hope this is the beginning of a journey of learning for you. We have a lot of training material on many different topics. If you don't know, we just launched a super cool training series called Kubernetes Masterclasses. We have training scheduled weekly almost through the end of May on many different topics. So please check those out too as the next step. And we'll also be starting a new advanced Rancher series starting next month. And then finally, we love learning, we love improving, we want to make this training as beneficial to users as possible. So we love your feedback, and we have a survey following the session. So when you exit, you should get prompted to fill out a short survey. It just takes a couple minutes. So if you're able to do that, we review it and use it to build out our new trainings and improve the ones we currently do. So just as a way of introduction, my name's Matthew Shear. I'm kind of like community advocate at Rancher. Super happy to be presenting this material to you guys. And I want to do a quick plug for the training channel that we've made just for everyone who's attending today's session. So if you go to slack.rancher.io, create a Slack username if you don't have one already. It's totally free. And then you join the channel training-0207, you'll be able to get to know each other, ask each other questions, find out what everyone is doing with this technology. That is the place during this training and afterward to stay in touch, keep connecting, be part of the community. And of course, last but certainly not least, our trainer on the line, Adrian Goins. So happy to have you, as usual, Adrian.
Great. Happy to be here. Hey, everyone.
Yeah, awesome. So before we get started, a couple things. We hope you come into this training with a basic understanding of Docker containers. There's a lot of material available on Docker, on Rancher, about containers. It is the fundamental building blocks for what we'll be talking about today. But if you don't know Docker, you don't know containers, that's okay. I think you'll still get a ton out of the session. I mean, you can always review it afterward because it is being recorded. And if you want to have your own instance of Rancher going as you view this session, you can easily get one started in just a couple minutes. Go to rancher.com, click the deploy button in the top right-hand corner, and it'll bring you to this quick start and then the quick start guide. It's just 2 steps to get your own instance of Rancher going. It takes just a couple minutes, and then you'll be able to play around and tool around while Adrian goes through his explanation and the demo. Lastly, there's important resources that our community loves and participates in. So as I mentioned already, slack.rancher.io, there's thousands of members on our Slack channel asking questions, hundreds of questions a day, conversation about all this stuff and lots of different channels. And then of course our forums.rancher.com, both of these resources are free. Ask away. Our engineers patrol those places too, trying to answer questions and being helpful. So if you do have further need of support, you can get it there. So with all of that housekeeping out of the way, we can get to the meat of the material, and I'm going to pass this presentation over to Adrian. He should be able to see his slides in just a moment. All right, I can see your slides. You're good.
Awesome. I will also unmute myself so that you can hear me talk.
Okay, good. That's helpful. That is
I have
helpful
like,
too.
I'm like mute button challenged. Like every time I'm in one of these things, I'm like, ah, where's the mute button?
Yeah.
All right. Hey, everyone. So my name's Adrian Goins. I am an engineer here at Rancher, and I am super thrilled to be introducing you to Kubernetes and Rancher today. I don't know where you are in your Kubernetes journey, but you're here, so that's great. Perhaps you started using Kubernetes, perhaps you're curious about Kubernetes, perhaps you don't believe in Kubernetes, but all of us can certainly admit that Kubernetes has taken over the marketplace. And I still talk to people who are like, oh, it's a fad, oh, it's a bubble, oh, it doesn't actually matter because I was in a marketing call with the Cloud Native Computing Foundation yesterday, and they threw out a number that astounded me that I think, if I remember, I'd have to go back to my notes to get it, but I believe they said 34% of the Fortune 500 companies are now running Kubernetes. And that is astounding. What it means for us is that whether you believe in it or not, learning these skills is an investment in your future. If you don't learn this, it's not going to be too far in the future before you will not be able to compete in the job market. So I commend you for being here. I commend you for learning. And I understand that all of this can be very daunting. So what we're going to do today is we're going to introduce you to some basic Kubernetes concepts. I'm going to show you a couple of slides about, ooh, Kubernetes is important. And then we're going to dive right into the nuts and bolts of Kubernetes. And then I'll transition later on to Rancher. So Matthew said, any questions that you have, throw them in the chat, and we will do our best to answer every single one of them, even if we have to go long. I also talk a lot, so I should probably move on. Otherwise, we're going to be here all night. So despite the fact that Kubernetes has taken over the market, and it seems like everyone is running it, it still has some challenges. Kubernetes itself is a very, very flexible framework for doing things. There are lots of ways to do stuff. I'll show you even today that you can do the same thing 4 different ways, and I'll do it all 4 different ways just so that you can learn it. But it's up to you to figure out how to bolt on the secondary components to build an actual infrastructure that's appropriate for you. So we hear these kinds of questions that you see on the screen from our users all of the time. So people who are using Kubernetes, oh my gosh, I'm watching my monitor like glitch out and make popping noises, and I hope it doesn't catch on fire. Okay.
Well, the slides look good, no?
Yeah, no, it just like started going pop, pop, pop and like glitching out. Okay, it's done. It's done.
Okay.
If I suddenly go, fire, I'll be right back.
Okay.
Anyway, so one of the Kubernetes questions is, if it catches on fire, what do you do? But seriously, as you go into this, you need to consider not just how to build the infrastructure that's appropriate for you, but you also want to make sure that whatever solution you choose today is flexible enough to manage your needs in the future. You may not know what you're going to need a year from now. And so no matter what platform you're looking at, it's good to think, all right, does this solve my problems today? And do I imagine the problems that I'll have in the future will still be met by this application? So you look at these things, and the things like authentication. We hear that people cryptojack Kubernetes clusters because people put them out on the internet with no authentication and API access. That's just a bad way to do stuff. Partitioning clusters, multi-tenancy, single and multi-cluster multi-tenancy, highly available clusters, security policies, monitoring. Having to figure this stuff out yourself is a terrifying prospect. The consequences of doing it wrong are severe. So our objective in creating Rancher is to give you industry standard certified tooling that you can just activate that solves all of those problems. So let's start at the bottom. You can pick your Kubernetes solution. You can build it yourself the hard way. I don't know if you've seen Kelsey Hightower's Kubernetes the hard way, which is like a recipe for suffering and pain, but it's a good introduction to just how challenging Kubernetes can be. But it doesn't have to be that challenging. You can use something like Rancher Kubernetes Engine, which will allow you to spin up a one or multi-node Kubernetes cluster built on top of Docker containers in the space of a few minutes. You can use a hosted provider like GKE, EKS, AKS, whoever gives you another provider solution tomorrow. It doesn't matter. Rancher can deploy and manage hosted Kubernetes solutions. It can deploy compute nodes into something like EC2 or GCP or DigitalOcean and then install Kubernetes on top of that. All of that bottom layer is essentially a commodity. Kubernetes itself is like electricity. You probably don't care where it comes from, but what you do care about is that when you flip the switch on in your house, the lights come on. So Rancher gives you all of that and then moves on to managing the Kubernetes clusters. And so let's talk about what management means. It means that you can corral all your clusters under one system, one highly available point of control, and that you're not going to sacrifice any of the individual cluster independence. It means you can bundle namespaces into projects. You can map strong authorization roles, granting access to those projects. And it means that you can plug your Kubernetes clusters into the infrastructure that you already have, like Active Directory or SAML or GitHub, or you can use the local users and passwords that are built into the Rancher platform if you don't have something else. You can control Kubernetes clusters running anywhere, literally anywhere. If it's Kubernetes, we can talk to it. It means that you can readily see and control your capacity, and therefore you can control your costs. Anybody who's done anything inside of any cloud provider knows how easy it is to get that bill at the end of the month and be like, oh my, what is this? And by then you've already used the resources, and so you're stuck. Having tooling that shows you what your infrastructure is now and being able to manage that now is extremely powerful. And if you're a cluster administrator or any type of system administrator or operations person, everything that I've spoken about probably gets you excited. And if you're a developer, everything I've spoken about probably makes you yawn. But Kubernetes and Rancher offer things for developers as well. So, I don't know what your objective is. Maybe you just want to spin workloads up and down quickly. Maybe you want to plug it into a CI/CD system. We've got a great UI that lets you deploy applications that are as simple or as complex as you need them to be, and to do so quickly. The last thing that we want to do is interfere with the developer's ability to do stuff rapidly. That's called velocity. Developers love it. You want to just push code, it gets out there, you test it. My monitor just went out. Okay, hang on a second, I gotta check this outlet.
Sure.
I
can still see your slide. So.
Oh, yeah, it's like popping and stuff. Okay. That's a little scary. And it totally messes up my flow. All right, so where was I in my notes? So yeah, developer velocity. We don't want to get in the way of that. We have a metric server and integrated logging, so you can plug into that. You can plug into an external logging platform of your choice. You can manage stuff with the Rancher UI, or if you're a power user already, you can do everything via kube control directly. So all of it exists. All of it adheres to all of the role-based access control that we build in from the beginning. And ultimately, it exists to give you flexibility. We have an application catalog. You can deploy stuff with Helm. You can plug into CI/CD systems. If you don't have a CI/CD system, Rancher ships with a pipeline system that you can just use right away, attach it to your repositories, push some code, watch it build, watch it deploy. Everything that we do is about giving you freedom. We want you to be able to do things the way that you want to do them. And the way that I do them is probably different from the way that you do them. And Rancher is never going to tell you what to do. We're just going to empower you to do things well. The best thing about Rancher is that it is 100% free and open source. Every single thing that we release, Rancher, RKE, Rancher OS, new stuff that we have coming up in the next couple of months, you are free to download, free to use. There's no community version versus an enterprise version. It's all there for you. Totally visible. If you are an organization that wants additional support, we do sell support contracts, but it is not required. And I'm not a sales guy, so I'm just going to tell you they exist. If you're interested, contact us. We'll tell you more. I am here to tell you about Kubernetes. Woo! Kubernetes, it's a funny sounding word. You start getting into this and suddenly it's confusing. If you're coming here from Docker, the words are different. But look, we're going to fix all of that today. Ultimately, Kubernetes is about building applications using basic building blocks. And that's it. So we're going to move through these pods, deployment services. We're not going to get to config maps because we never have time, and ingresses. And we're going to build a little simple application. By the end of this, you'll feel comfortable. So we'll start with pods. So imagine you're sitting there with a container image that you want to deploy. If you use Docker, you might just say Docker run. You might expose some ports. But have you ever gone through the hassle of trying to link containers together so that they can find each other by name? Have you ever ported an app that maybe expected MySQL to be on localhost? If you've got a couple of containers, it's not a big deal. But when you get to where you have 3 or 5, where they start running on different hosts, it rapidly becomes a problem. I like to remind myself that all of this technology that we surround ourselves with is supposed to make our lives easier. It's not supposed to make our lives harder. It's not supposed to make them more confusing. So as I'm going through this training today, just remember that all of this is about making life simpler. So a pod, smallest unit of deployment, usually will have one container, but it can have more, has its own IP address, and containers in a pod can speak to each other via localhost. Ultimately, you can just think of a pod as a thing that collects containers into a shared unit with combined network space and combined storage. That's basically it. 99% of the time, I say 99% of the time. I once heard that 46% of all statistics are made up on the spot. So understanding that, I'll tell you that 99% of the time, you're going to have one container per pod, but sometimes you won't. Best practices for Docker containers dictate that you should have one process per container. And that's cool in theory, but actually challenging to do in reality. Kubernetes pods make it easy to adhere to that practice. Don't be confused about pods. If this is new, just every time I say pod, think container, because ultimately, that's what we're going to be deploying today, and that's what you're going to do most of the time. So here's a sample pod with 2 containers, and this gives a good example of how each container might do a different thing. So you've got a file puller that pulls content in from a CMS, saves it to a volume, and then the web server that's in that container makes that content available to consumers. It's a pretty basic circular system. This is a great example of a multi-container pod. When you think about pods and how to assemble them, think about them as a scalable unit. If your application needs more horsepower, you're going to start by going from 1 to 2 to 3 pods, and then maybe to 5 or 10. It's what's inside the pod that matters because you're cloning it. So that's why you don't want to do things like put a web server and a database server in a pod, because you're never going to scale that to 15 database servers. Web server, file puller, web server, caching system, things like that that work together to deliver a service are good to bundle together into pods. Kubernetes uses what are called manifests. Manifests control resources, and manifests are written in YAML. You can also write them in JSON, but we're going to do YAML today. So you'll create a manifest, and then you use kubectl to apply that manifest to the cluster. Kubectl, you might say kubectl, some people say kubectl. Call it whatever you want. It's a command. This is a basic manifest for a single pod. It has all 4 required keys for a manifest, which are API version, kind, metadata, and spec. I have to say that those are the 4 things that all manifests have. Don't pay it too much attention. Look down in the spec part where it says containers. It's got 1 container. Its name is my app container. The image is busybox, and we're giving it a command. The command is to say, hello Kubernetes, and then sleep for 10 seconds. Cool. We'll run this now. And I want you to think, what's going to happen when that container finishes doing that task? And now I must switch to this. All right, so there's our pod. I actually only had him sleeping for 5 seconds because 10 seconds was too long to wait. We have no pods running. Let me make sure I'm on the right cluster. I am. All right, so you'll see me type KC. KC is because I got tired of typing kubectl, and so I made a bunch of abbreviations for it. So, I encourage you to do the same. As system administrators, it is our obligation to be lazy. So we're going to apply the file pod.yaml to the cluster. And it says it created it. Okay, let's take a look. Okay, it's there. It's creating. Okay, now it's running. Still running. It finished. What's going to happen? Okay, it's running again. You see restarts equals 1. Running. Finished. Clear my screen here so we get some stuff at the top. And in a moment, we're going to see crash loop back off. The reason that we see this is because when we're running a pod, Kubernetes expects that pod to stay running. You generally have things running inside your cluster that continue to run and continue to do something. Sometimes you don't. Sometimes you'll run things that are called jobs. We'll talk about them in the future. But because Kubernetes expects that in general, whatever your thing is doing is going to continue doing it, when it sees it die, it restarts it. And then in our case, it died again. Well, it exited, but Kubernetes doesn't know that. Kubernetes just knows that it died. And so rather than restarting it again and again and again and again and again, it's going to start waiting longer and longer between restarts. This is called a backoff. Completed. It's going to fail. Well, it's going to exit again in 5 seconds, and then that will continue. So consider that Kubernetes' job is to keep things running. That'll become more relevant here in a second. My notes. So we will just nuke this. Oops, there we go. All right, so we'll delete that and we will move on to the next thing. So the next thing is a replica set. Replica set is one level above pods. A replica set is a resource that tells Kubernetes the scale and state for a group of identical pods. So for example, if you tell Kubernetes that you want 3 replicas of a pod, and replica is just a fancy way of saying copy, and there are 0, Kubernetes will do its best to make 3 of them appear. Here are 3 nodes. Each of these nodes is running 4 replicas of our pod, 12 replicas in total. Kubernetes has been kind enough to distribute all of these pods across our 3 nodes. Now imagine something happens. One of the nodes dies. Kubernetes saw that we wanted 12 replicas and that we only had 8. Did what it does, and it moved us from the actual state to the desired state. And this is how Kubernetes manages state. It's always working to maintain the desired state. Now, it monitors the health of pods via a number of different means. The basic level is the container running or not? You can also do health checks via HTTP or HTTPS. You can do port checks via TCP. You can also have Kubernetes run a command inside the container that has an exit status that determines whether the container is healthy or not. There are also 2 types of health checks. There's a liveness check and a readiness check. A pod won't receive any traffic until it passes the readiness check. So imagine something that needed to like prime a cache. Once the readiness check passes, Kubernetes will switch to the liveness check. And if that fails, then it'll restart the pod. You can also configure health checks with a delay before Kubernetes starts checking things. So if you have something like GitLab, which takes forever to start, you can tell Kubernetes, look, don't restart this for 5 minutes, or don't start checking it for 5 minutes. If it's still down, then go ahead and restart it. Can't type. All right, here's a replica set. You got your same basic thing. So API version, kind, that tells Kubernetes what kind of resource we're creating, metadata, and spec. Now we're going to start talking about these. Metadata contains things like the name for the resource itself. In this case, we're going to call our replica set front end. And then you can have arbitrary labels. These are simply key value pairs. So in this case, we have app as nginx, tier is front end. We can also have it, color blue and temperature hot. Doesn't matter, whatever we want. Labels are important within Kubernetes because they're used by things that do selection. What does that mean? Well, let's move down to the spec. We want 3 replicas. Oh, look, here's a selector. We'll come back to that. Down here under the template, this tells Kubernetes what it's supposed to do. What is this replica set managing? We say, all right, it's managing something that will have this metadata, app nginx, tier front end. And you come down to spec, containers, and this is a list. If you know YAML, you recognize that as a list indicator. So we have 1 container in our list, and it's actually all the way down to there. We have 1 container in our list. Name is nginx, image is that. Don't worry about resources. I throw these out here just to show you that you can tell Kubernetes how much CPU and how much memory this thing needs to be allocated, or how much it's allowed to use. If it exceeds that, Kubernetes will kill it. And then this part will actually become relevant later. So back up here, 3 replicas. What are you managing? You are managing pods that either have the label tier front end, or this is a more complicated expression that says that it can have multiple values in the tier label, And as long as one of those values is front end, then that's also a match. Down here, notice that the pods that it's creating will have the label of app equals nginx and tier front end. Sweet. So we will apply this, and we see we have a replica set. We want 3. We have 3, but 0 of them are ready. 3 what? 3 pods. Our replica set is called front end. Now, if we look at the pods themselves, you see that they're running. And notice their names are now a little bit different. The name is replica set dash unique identifier for this particular pod. If we look back at our replica set, you'll see that we now have 3 of them are ready. You're never going to make replica sets. The reason you're never going to make replica sets is because managing things with replica sets isn't very much fun. I was going to say a different word, but it's not fun. If you wanted to change something that's running, you have to delete pods and restart them and stuff. There are better ways to do it that make your life easy. It's important that you understand what a replica set is, because the next thing I'm going to show you is the next thing above replica sets. I will, however, show you that if we nuke one of these pods, by the time this command returns, the new pod will already be running. I don't know why this sits here. All right, so you see we nuked 45RMV, it's gone, and now we have 6N9GL. So Kubernetes, actually, sorry, we have this guy, DW4PX. DWP4X. So Kubernetes did what it's supposed to do. We want 3, we had 2, it made a 3rd one. That's it. If we delete this now, we go to get our pods, you see that the pods are also terminating because the replica set controls the pods. Let's talk about the next thing. Deployments. Deployments are a level of abstraction above a replica set, and this is why you're never going to make replica sets. Deployments make them for you. They create replica sets, and they give you a really nice set of commands within kubectl that you can use to control the replica set, control the pods, and do updates to the images, and do various other things. I'll pause here and tell you that deployment is one type of controller. Controller controls things. It's obvious, but it's worth saying. Deployments control replica sets control pods. But there are other types of controllers. Use deployments for replica sets because they make lots of copies of the same pod. All of those pods are identical. Any one of them is as valuable as any other. You can shoot one and it'll just get rebuilt and it doesn't matter. It can move to a different node. They all do the same thing. There's nothing special about them. And when you're building applications that are stateless, deployments are where you're going to spend your time. You always want to build applications that are stateless. But sometimes you can't. What's an example of a stateful application? Stateful application is where you have a pod that needs to know who it is, or maybe it needs to know who its friends are. So if we had, for example, a Redis cluster, you got a master and 2 secondaries, I forget what they're called in Redis, 2 slaves. But let's talk about databases, MySQL. So you've got a master and 2 slaves. Well, they are special. The slaves need to know about the master. The slaves themselves are different from one another. They need to come up with a stable name. They need to be able to find one another. They need to come up in a specific order. That's state. Kubernetes gives you a controller called a stateful set. Stateful set is used for launching pods that require state. There is also a controller called a daemon set. Daemon set launches one copy of the pod on every single node. So if you have a 3-node cluster and you launch a daemon set, you'll get 1 pod on each node. And if you add a 4th node to the cluster, Kubernetes will put another pod on there. Now you have 4. And it will continue to do this for as many hosts as you add. There's also job. Job isn't really a controller, but it's a resource type for pods that start, do something, and then exit. So had we launched our pod earlier as a job instead of a pod, well, so I guess the job is a controller. The job controls a pod, but when the pod exits, it doesn't restart it. So that's good for things like dumping databases, etcd snapshots, running backups, chewing on log files, like anything that's a batch function that does its thing and then exits is a job. Now, if you need to do those things at a regular interval, the last controller type is a cron job. Cron job works exactly like a cron job on Linux. It starts jobs at a scheduled interval, and then when those jobs exit, they go away, and the cron job starts them again later. Today, we're only going to be covering deployments, but I have to tell you about the other types so that you can start to think where they fit in the applications that you build. So here's our replica set again. We defined a deployment, says we want 4 replicas of our pod, and we want each of them running an image with a specific tag like 1.0. A lot of instructions that you find on Docker Hub say, oh yeah, just run, Docker run image : latest. Don't do that with Kubernetes. Always run a specific tag for the image. Or if you don't have a tag, you can use the SHA ref, which is like a 26-character alphanumeric string that represents a specific build, and use that. The reason that you want to do this, the reason you don't want to run latest is, so here, imagine we've got 4 pods, and let's say all of them, instead of running version 1.0, they're running version latest. And let's say that one of them dies in the middle of the night, or there's a problem with a node and Kubernetes decides to kill that pod and move it somewhere else. If you're running the tag latest, it means that every single time that pod launches, Kubernetes is going to go out to the internet and it's going to fetch a new copy of the pod and it's going to bring it down and it's going to run it every single time. Well, if you don't control the release cycle of whatever you're running, then you might find that they went from version 1.0 to version 2.0 and you didn't know. And now you're asleep, pod dies, Kubernetes restarts it, and now you've got 3 pods running version 1.0 and 1 pod running version 2.0, and all hell breaks loose. Just don't do it. Use specific tags. So here we are, we're running version 1.0, and now we want to run version 1.1. So we update the deployment and we tell Kubernetes, change the image to version 1.1. It happily starts up some new pods running version 1.1. It keeps the old pods running. It then starts to kill the old pods, and then it launches some new ones, and then it kills the old ones, and then that becomes our new deployment, and now we're running version 1.1. So Kubernetes understands that we moved from one state to another, and if for some reason version 1.1 doesn't work, I mean, hopefully we tested it in our development environment, but let's say we didn't and something went wrong, we can roll back to the previous version. Kubernetes will let you roll back once. If you're doing your deployments with Rancher, you can roll back infinitely. We keep a diff of the config going back to the beginning of the deployment, and you can view those and roll back. I mean, I don't know why you would want to roll back to the version from 2 weeks ago, but should you need to, Rancher's got you back. So now we've got a deployment. 1 or more pods. How do we talk to them? To do that, we'll use a thing called services. But before we do that, let's demo some deployments. Here is a deployment. And it looks kind of like a replica set. In this case, we're saying we want 1 replica. We're going to match some labels. The rest of it looks the same. We're going to run that particular image. And I'll still talk about this part again in a second. Now, I'm going to apply this differently. I want to show you this deployment. But you don't always have to sit down and write YAML. Writing YAML, like that, I don't want that for a job. And especially when you get into things that are like 400 lines of YAML, nobody wants to do that. It's unforgiving. You make a mistake, it yells at you. It's not obvious where your mistake was. So let's do something different. Kubectl has, can't talk and type at the same time, so I'll just type first. Okay, kubectl has a command called create. And then you tell it, what do you want to create? I want to create a deployment. I want my deployment to be called Nginx, and I want it to run that particular image. And if I go and do that, you'll see that we have a deployment. which created a replica set, which created a pod. And so our deployment is Nginx. Our replica set is Nginx dash some unique identifier, and our pods are Nginx dash replica set identifier dash pod identifier. And it's running. And that's a great way to really quickly deploy something. Now, if I were to fetch that, oh, that was really big. If I were to fetch the YAML for that deployment that we just created, you'll see that it looks, I mean, it's got a lot of other stuff in here that's not necessarily useful. It's like statuses and things like that. But within here, we have all of the same stuff that we had before, plus a bunch of other defaults about updates. Here's your container, here's your image pull policy, and so on and so forth. So if you need to get this, you can just do your deployment really quick, and then grab that, save it, there it is. And just to show you that this actually works, there you go. So we can just reapply it. So you don't have to create this YAML. You can create the thing using kubectl and then go and get the YAML. Or I'll show you some other stuff a little later on about how you can interact with the YAML. So let me actually delete that again. And here was our deployment. Let's remove that. There was our deployment. Let's just apply that. And it's going to go and create it. And so there we go. Now, we have a pod. In our case, the pod's running. That's cool. But remember earlier we had crash loop backoff, and maybe we don't know why that's happening. So you've got some options. The first one is you can look at the logs for the pod itself, which has no logs because it's Nginx and it hasn't done anything. So that's not very useful. But we can also look at how Kubernetes sees the pod. For that, we use the describe command. Describe, well, that's exactly what it sounds like. Describes things. But this is from the Kubernetes perspective. So you can see cool stuff like what namespace is it in, what's its IP address, what's its status, a bunch of other stuff. But what's interesting down here is the events. So you'll see that it assigned it, it already had the container image, it created it, and it started it. When you have Kubernetes reporting an error, this is the place that you're going to look for why that error is present. We're going to do that in a minute. But first, we've got one pod. Now, this is Nginx. It's our website. Our website, we just launched it, and we're really excited, and we ended up on Hacker News, and now we're getting a whole bunch of traffic because nobody's ever seen the default Nginx webpage before, and they're just blown away. So we need to scale it. Kubectl, scale. What are you scaling? The deployment called Nginx. And what do you want? We want 3 replicas. Boom. 3 replicas. That's one of the things that deployments gives you that makes life easy. Now, obviously, you're not going to be sitting there in reality manually scaling your stuff up and down. Kubernetes has a thing called horizontal pod autoscaling, which you can define rules based on requests per second or CPU load, memory consumption, things like that, where you can tell Kubernetes when it needs to actually scale your application up or down, and it will do that for you automatically. We're not going to cover it today, but just know that it exists because it's cool. So now we've got 3 pods, and they are all running that 1.14 Alpine. Let's change that to something else. So another deployment option that kubectl gives you is the ability to set the image. Now what we're saying is set image on the deployment Nginx. And because a pod can have multiple containers, we have to tell Kubernetes which container we're playing with. In our case, we only have one. However, we still have to tell it. And what do we want to set it to? We want to set it to that. And we want to record. If you don't have dash dash record in the upgrade command, you will not be able to roll back. So you should just always have that. So we're going to go ahead and do that. And we're going to go and get our pods. And oh, something bad has happened. Notice that Kubernetes started the new pod, but all the 3 old ones are still running. Now, that's the default behavior. We can tell it to kill the old ones and then start new ones. You can do all sorts of stuff, but by default, it's going to roll out new pods. It's called a rolling update. It's going to roll, launch one, kill one, launch one, kill one, launch one, kill one, and then you've rolled to the new thing. What's nice about that is if your rollout hits an error, well, your application is still running. So you've got time to figure it out. How are we going to figure out what just happened? We're going to describe it. And in describing it, we're going to come down here to the events. And we're going to see, okay, image pull, back off pulling image. Oh, because like half my text is missing here. There we go. So back off pulling image, and we see that we misspelled Alpine. So easy enough to fix. First of all, I'll introduce you to the rollout status command. We are doing a rollout, and if you run rollout status, it will continue to update with the state of things. So you see 1 out of 3 new replicas have been updated, and had we sat here for a while, we'd have figured out there's a problem. This will sit here forever, so we're not going to stay there. But you also have, in addition to the status option, rollout undo. And so if you're in the middle of a rollout and if something goes wrong, you can say rollout undo, or if you rolled it out already and something went bad, you can undo it to go back to the previous one and it gets rolled back. So we tried to upgrade and we used the wrong image. I told you earlier, there's lots of ways to do things in Kubernetes. I'll show you here. We can edit. Whoops, not editing ingress. Deploy Nginx. And let's go find the image, which is down there. And we're going to change 14 to 15. No, mistype that. And we're going to save and exit. And there you go. So if we go back to status, oops, you'll see that 2 or 3 replicas killed it off, successfully rolled out. And so there we go. Those are deployments. Deployments are where you're going to spend most of your Kubernetes life. Let's talk about how to get stuff from the pod to the rest of the world. We'll start with services. Pods have an IP address, but you can't really trust it because pods are transient. So Kubernetes can kill it and restart it. It can have an issue, it can restart it. If you have something hard-coded to talk to the IP, that IP is going to change, and eventually whatever's talking to it is going to not be able to talk to it. So services are an abstraction above pods that give you a stable DNS endpoint that refers to a group of pods. So basically, as pods are coming and going and starting and restarting or scaling up and down, the service knows where they all are and will always send traffic to one of them. And by default, it just round robins across them. And as long as you're building stateless applications, that's fine. There are several service types. Cluster IP is an IP address that exists only within the cluster. And this is cool if you have like a service in front of a database and or different like microservices style applications. So you have one group of pods needs to talk to another group of pods, and that traffic never needs to leave the cluster. We'll just have it talk to a service of type cluster IP. Next above that is a node port. Node port will open a high-level port on every single node within the cluster. And doesn't matter which node you land on, if you hit that port, it's going to get routed to one of the pods that are sitting behind the service. Then above that is load balancer. Load balancer works if you're deployed in a cloud provider, so Amazon, GCP, or if you're using something like Metal LB, which is pretty cool. That's for on-prem environments. When you deploy, let's just talk AWS. So if you deploy a service of type load balancer, what Kubernetes will actually do is it'll create a cluster IP service, and then it's going to create a node port service that points to the cluster IP. And then it's going to go out to the cloud provider, in this case Amazon, and it's going to create an ELB. and it will configure that ELB to talk to the ports that it opened on the hosts, and then traffic will go back in. It will maintain those ports. So it will continue to keep that load balancer up to date, and that's how you bring traffic. It's one of the ways to bring traffic into your cluster. It looks like that. Whatever, this is your standard load balancer type description. So let's talk about services. All right, do I still have something running? I do, right? I've got my Nginx stuff running. I do, that's fantastic. Lots of ways to expose a set of pods via a service, but easiest one is to do what I just said. Group control expose, give it a deployment, it will figure out what it needs to do, and it's going to go and create a service. So service Nginx node port, we see that it's listening on port 30591. And if we were to go to that, I only have one node in my cluster today. And what's his IP? His IP, oh my gosh, that's a terrible thing. You are NP0A, 172, you are that. So if we come over to here, make a new tab, go to that, and I forgot what my port was, 30591. There's our Nginx welcome page. Not very exciting, but demonstrates that it works. Now, much like you're never going to be dealing with replica sets, you're never going to be dealing with node ports because you're not in the business of managing ports. You don't want to handle port collisions. You don't want to maintain a wiki of which application is on which port. But if you are using load balancer service type in a cloud provider, you at least need to know how this works. Running out of time for this portion, so I will show you. Let's delete the service, and I'll show you an alternate way to do this. So I have this service YAML here. I could do kc apply -f service.yaml, and that's one way to do it. Another way that I could do it is I can use kubectl create. I never do this. Service, node port, Nginx, node port equals 3. So if you did want to be in the business of managing ports and you wanted to create something quickly, create a service on a specific port, here's a way to do it. So create a service, type node port, name it Nginx. This is the node port we wanted to listen on. Service node port. And actually, yeah, so there you go. You see that it actually created it with the correct port. We're going to remove that, and we're just going to create it here as a type cluster IP, because in a moment, I'm going to show you how to take a cluster IP service and expose it outside of your cluster without having to pay money for a cloud provider load balancer. That is called an ingress. PowerPoint. All right. An ingress takes a service and exposes it outside of the cluster. The Kubernetes component that does this is called an ingress controller, and it is responsible for configuring a software load balancer within the cluster to route traffic, usually by host name and optionally by path. So if you imagine a microservices application where you've got different groups of pods doing different things, /store, /search, /something, /cart, you can have a software load balancer that routes each of those paths to the corresponding service and thus to the corresponding pods. So ingresses are important for microservices type applications. The default ingress controller that ships with Rancher is the Nginx ingress controller. It's particularly useful because it will also load balance UDP, in addition to doing arbitrary TCP ports or HTTP and HTTPS workloads. But if you don't want to use it, you can also use HTTP proxy. There's traffic, which does some other cool stuff. There are also ingress controllers that integrate with external hardware load balancers like F5 and A10. So there are tons of options, and you can even run multiple ingress controllers on your cluster and have them handle different groups of services. As I said in the beginning, Kubernetes is endlessly flexible. So if you have a service of type cluster IP that lives inside your cluster, you got the ingress controller that sits on the outside, and it looks like this. Traffic comes in, it's virtual host type load balancing, and then it just routes traffic. To launch that, we will show you two different kinds of ingresses. The first one is a simple ingress or single ingress. This is simply, oh, that host is not going to work. This is simply that's him. All right, so this is going to intercept traffic that goes to this port that goes to this IP on this port, and it'll route slash to the appropriate thing. And this should work based off of IP. If not, I will, ooh, nope, must be a DNS name. Okay, I will introduce you to something super cool. XIP.io is a slick DNS service run by the same people that give you Basecamp, where basically anything that you request .xip.io, so it's going to be something with an IP address .xip.io, it will just return that IP. So if I say host 1.2.3.4.xip.io, then it's 1.2.3.4. And you can do this going back infinitely. 1.2.3.4. So if you run into a situation like this, where you're testing something, you're doing development, you don't have a host name, you don't want to go configure Etsy hosts, then that is a great way to get a host name. So we'll apply that. And while that, let's just discuss what it did. So we got the host name, we're routing slash to the Nginx service on port 80. And with that, we can now come back to our browser, and we'll just use the whole host name. And once again, there we are. There is our Nginx welcome page. That's the simplest way to use an ingress. However, let's talk about a more advanced example. This is called a fan out. A fan out is a fancy way of saying direct different paths to different services. Change that again. And you see here, we're going to direct slash to the Nginx service, and we're going to direct slash rancher to the hello world service. Those of you who have been paying attention probably have already figured out that there is no hello world service. So what do you think is going to happen? All right, so we got that. So I got our service, everything's still fine. We come over here, we say reload, that reloads. And if we go to slash rancher, we get a 503. Oh no. 503 is the internet's fancy way of saying, I don't know where to send this traffic. You've told me to send it to something, and that thing doesn't exist, is down. I don't know. It's load balancers raising their hand and asking for help. This is because we don't have a service called Hello World. So let's make that. That's going to take a second to build. And while it is building, let's do this. I'm going to expose this, and it's going to fail. Earlier, when I showed you deployments, I showed you that all of them have this little thing down here. So this tells Kubernetes that this container listens on port 80. Without it, if we are trying to expose a deployment, Kubernetes doesn't know where to send the traffic. It's like, well, you didn't tell me what port to send it to, so I don't know. And it will fail the expose command. You can fix this by either editing your deployment and putting that in there, or you can just tell it what port to use. All right, so Hello World is running, and we have a service running. And so now we should be able to come over here and there we go. So now we just built a little useless microservices application where we have two different sets of pods doing two different things, and we are successfully able to route traffic between them. See our request information here, and if I reload this, you should actually, oh, Hello World only had one. Scale, deploy, Hello World, replicas equals 3. Oh, it's already done. And now if I start reloading, we should see the pod name change as we round robin traffic across it. So that is your crash course into directly interfacing with Kubernetes. And I'm going to pause to take some questions, and then I'm going to show you how to do more or less the same stuff with Rancher, and it'll be a lot faster. So Matthew, what do we have for questions?
Awesome, Adrian. Okay, let's get to the questions. First one is from Wim, who asks, can any application be placed into a pod, or are there application requirements to do this?
Can any application be placed into a pod? Oh, theoretically, yes. The main thing so your requirements are the same as they would be for a Docker container. Your whatever service it's running needs to stay in the foreground. You want to run just a single service, and there are some applications that are less well suited for running inside of containers, but theoretically, you can. If you've got a big old monolith or something that requires a whole bunch of intercommunicating things, like imagine Apache with fast CGI talking to PHP, and you've got a separate PHP container that has stuff running in it. That would be better suited for a single pod with two containers. You don't want to bundle those things into a single thing. So if you're porting applications, try and consider if they should be broken out into either multiple pods or multiple containers within the same pod.
Cool. Okay, awesome. Thank you, sir. Next question. It's actually broken into two. I think I understand. He's saying, is the replica set the same approach to VM clustering? Is the replica set the same approach to VM clustering?
The easy answer to that is no. But I also don't understand the question. If he wants to clarify, we can try and hit it again.
Wim, if you could re-say your question, because you broke it into two different lines, so maybe you're referring to different things. Okay, cool. The next one is from William, who says, can you use an ingress to route traffic that is not HTTP or HTTPS?
Absolutely. So I use the Nginx ingress controller, and I route TCP and UDP traffic. For example, if you have a backend that doesn't speak HTTP, like maybe MQTT, or you're running like an SSH-based thing or something, you can route TCP. And then you can also route UDP if you had, for example, an OpenVPN server running in a pod. All ingress controllers can do TCP, Nginx, and I think maybe traffic. I'm not sure, but Nginx for sure can do UDP.
Cool. Okay, great. Next question. How does pod-to-pod communication happen?
Pod to pod. Your pods will never need to talk to one another. If you're building a stateless application, each pod thinks that it is a unique and special snowflake alone in the world, and it has one job to do, and it's going to do that until Kubernetes comes along and kills it. However, if you have a different set of pods that do a different set of things, and pods in set A need to talk to pods in set B, you will put a service in front of the other set of pods, and then that gives you a DNS name. Let's hang on a second here. So that will give you a DNS name that in a moment I'll be able to show you. The DNS name is of a known format, so this is going to take a while to create. Let me just show you the services here. So we're running in the default namespace, and we have an nginx service. So any pod in any namespace can communicate with nginx.default.svc.cluster.local. So .service.cluster.local is what SVC translates to. And so as long as you know that your other pods are behind a service called nginx and they're in the default namespace, then they can just talk to them. And that service is responsible for directing the traffic to the pods behind it.
Okay, awesome. Thank you. Okay, here's the next one from Ruslan. He says, what about storage? How can we use our own storage like a local path?
Ooh, okay, so those storage is challenging, which is why it's not in this introduction to Kubernetes. Kubernetes uses a thing called a persistent volume, which is essentially it's like a disk, but it can be of one of like 50 different kinds of storage backends. And then you create a thing called a persistent volume claim, where a pod claims access to that storage. And if your storage is there's a specific word for it, but basically where you can read write many, like NFS, then you can have multiple PVCs writing to the same backend. But in most cases, your PVC to your PV is a one-to-one relationship. So when you get into pods, you think, okay, if I need to scale my pod up, how do I attach more storage to it? Depending on how your stuff is configured and where it's running, you can have what's called a storage class. And a storage class is you tell Kubernetes how to provision storage somewhere on Amazon EBS, on NFS, on iSCSI, on Ceph or Gluster or whatever, lots of different ways. And then when your pods want to create storage, they just ask the storage class for some storage, and the storage class gives it to them. And it handles this bridging between them. If you imagine that you're scaling a website, for example, from 1 pod to 10 pods, you're not going to want to provision new empty EBS volumes. So your website content is probably going to be bundled into the pod itself, or you're going to put it on some type of shared content resource like Ceph or NFS. There are a lot of really cool storage solutions that do things with distributed block storage. There's Longhorn from us, which is alpha right now, but will hopefully be generally available later this year. There's OpenEBS, there's Storage OS. All of these try to solve unique problems with storage, and storage has a host of problems. Just because it's really difficult to scale things up and down and get access to the storage that you need in a reliable way. It's a very long answer to the question.
That's okay. It's a complicated topic. Very good. All right, here's the next one from Robert. For setting up DNS, what IP is set for hostname? Is this the public IP of one of the nodes in the cluster, or does the Ingress load balancer have a separate exposed public IP?
Can you read that again?
Yeah, of course. There's a couple questions in one. So first, for setting up DNS, what IP is set for hostname? And then he says,
okay, for setting up DNS, what IP is set for the host name? Yeah. Okay, read the rest of the question. I think I know what he's asking.
Okay, cool. The rest of the question is this the public IP of one of the nodes in the cluster, or does the Ingress load balancer have a separate exposed public IP?
Okay. I think I know what you're asking, and so I'm going to answer that question. If I get it wrong, ask it again. The Ingress So the ingress listens you can configure it a couple of different ways. If you have a 50 node cluster, you're not going to have it listen on every single node, but you can make it a daemon set, and it will launch a pod. PO and Nginx. So you see here we have an Nginx ingress controller that's running. We only have one node in our cluster right now, but if I had 3 nodes, you would see 3 of these running. So it listens on every single node. Now, like I said, if you have a 50 node or a 1,000 node cluster, you're not going to have it listening on every single node. So in that case, you would deploy your ingress controller as a deployment, not as a daemon set, and you would tell it which nodes to run on. So imagine you have like 3 nodes out of your cluster where this is listening. And much like a service of type node port, it doesn't matter which host the traffic lands on, it'll get routed to the correct service and pod and stuff behind it. So for DNS is also an interesting and challenging problem. Obviously, you don't want to just put 3 IP addresses in there, because if one of these nodes goes down, DNS doesn't know. So it's going to send some portion of your traffic to a dead endpoint, and that's just bad. So you want to go with, you have a couple of options. One is in front of your cluster, you put some type of other load balancer that has the ability to health check those ingress ports. So for example, in my production cluster, I run HA proxy. This is an on-prem cluster in my house. I run HA proxy in front of my Kubernetes cluster, and that's where I direct all of my traffic. And I just tell HA proxy, send it to all of my Rancher nodes. And HA proxy figures out if one of those nodes is down, it just doesn't send traffic to it. If you don't have an external load balancer, but you're running in like AWS, for example, or DigitalOcean, or someplace where you can get one of their load balancers, you can simply punch TCP through. So you can, instead of routing HTTP or HTTPS, you can punch 80 directly to 80 and 443 directly to 443 on your cluster. It'll do the health checking as well. In Rancher 2.2, so what you're seeing today, what I'm going to show you is Rancher 2.1. Our current stable version is 2.1.5. And we have a preview release of 2.2 that came out on Tuesday. You can find information about that on our website. And it's super alpha, don't run it in production, but it includes a thing called global DNS. Global DNS is, in the case of 2.2, it's used with multi-cluster applications, which is also pretty advanced. But what it does is it has the ability to health check the endpoints and maintain a DNS record. So it will either work with Route 53 or it will work with Cloudflare. And in the case of a multi-cluster app, it will monitor both of those clusters or all of those clusters. If one of them goes down, it will update the record and pull the IP address out. That is built on top of a thing called, this is all more advanced than what we're supposed to get into today, but it's a really good question. So external DNS is something that you can deploy into your cluster, and whenever you expose a public port on a host, it will update and manage a DNS record in like Route 53 or Google Cloud DNS or Cloudflare or whatever. So what this means is you attach this to your ingress, and wherever that ingress is listening, that IP address goes into that DNS record. It requires some additional configuration of your cluster, but it's all dynamic and magical. And if something goes away, it updates the record. So it's essentially round robin DNS with management by Kubernetes.
Amazing. Okay, cool. Thanks, Adrian. All right, there's 2 more. So let's just do these fast and we can get into the Rancher stuff. What is the KGPO command?
Oh, that's just an alias. Kube control get pods. That's what it is.
Okay.
I have lots of aliases because some of this stuff just gets to be really annoying to type after a while.
Awesome. Thank you, sir. Okay, last one. Are you using fish as a shell?
I am. Fish rocks.
Sweet.
Okay. So because I'm running on a slightly different environment today, I am not operating out of my house. I need to actually nuke the node so that I can rebuild it. So let's do that. And then I have a snapshot here that I'm going to restore, and then I'll fire that guy back up. Oops. Okay, good. Pre-install, restore. Do not want a snapshot. Give me just a second, everybody. Okay, and now. If you want to run Rancher, so there's tons of ways to run Kubernetes. There's RKE, which will build you a Kubernetes cluster very, very quickly, but it's still pretty complicated. If you just want a really basic way to play around with Kubernetes yourself, there's a cool project called Kind. And that's Kubernetes in Docker. So that'll build you a one node Kubernetes cluster. That's them, but it doesn't give us their repo. Look up Kind, and it'll build you a one node Kubernetes cluster. It runs everywhere. It'll run on Windows, Mac, everything, any place that you can run Docker. And that's a cool place, a cool way to just start playing around with it. If you want to do something that's a little bit more advanced, we have so actually, yeah, we'll go to the quick start. So you can go to our GitHub repository for quick start, and here we have Vagrant, DigitalOcean, and AWS. So Vagrant is just Vagrant scripts. AWS and DO are Terraform scripts, and they'll actually spin up infrastructure for you and deploy. The quick start will actually deploy the entire thing, nodes, RKE, and Rancher itself. And you can also go to Rancher Rodeo, and if you go here, this is actually what you see me running right now. Inside of Vagrant, it'll actually just build you the nodes, and then you can follow the steps that I'm about to execute to launch the Rancher server. So let's jump back into node 1. And if I did this correctly, then we just have the agent. Fantastic. Okay, let's come over here to the server. And let's kill that. And let's kill that. All right. We have 2 nodes. We have a server and we have a node. Rancher is super easy to run. I'll explain this in a second. Don't worry. Okay. There's a couple of ways you can run Rancher. If you just want to spin it up and play with it, the easiest way is what's called a single node installation, where it runs inside of a Docker container. And that's what we're doing here. This is not production grade. If you want to run production grade, you want to run a 3-node RKE cluster and install Rancher into it using Helm. The instructions to do that are on our website. Our documentation is quite good. Oh, wow. Apparently my browser is too small. Rancher docs. And we'll go to read the docs. And under installation, you'll see that you have options for single node or HA install. If you think that you might put production workloads on this, just get 3 nodes, run RKE right now, because there's currently no way to go from the standalone container to the HA installation. You don't want to have to rebuild all your stuff. If you do go this route, our documentation does not have this in it. What this does is this says bind a local volume on this host to this within the container. And the reason that you want to do that is because since I'm running this in a container, if I nuke this container, I'm going to lose all of my configuration. So we don't want to do that. We want to at least save it on opt Rancher. We want to run this with the right command. So Docker run daemon restart unless stop, pass through 80 and 443, bind amount of volume, and spin up the server. I'm just going to become root. Yep, so that is starting. And in a minute, or less than a minute, it will appear. There we go. You can attach certificates from Let's Encrypt. You can also attach your own certificates if you have it. If you don't give either of those, then it's just going to create its own self-signed certificate. And so your first time visiting it, you're going to get the, oh my God, the universe is going to end error. Once you get past that, it's going to ask you to create a password. Do so. And then it's going to ask you, what is the Rancher server URL? This is important. When you attach clusters to the Rancher server, this is the address that it is going to use. This is the address that they are going to use to communicate with the Rancher server. So if you're running in like AWS or something, no problem. But if you build the Rancher server in your office and you try and launch something out in AWS, they need to be able to, the nodes in AWS need to be able to reach whatever you put here. So for today, I'm just going to give it the IP address. If you do get this wrong, you can change it later. It's not that big of a deal. Just understand that it's important. And that takes us to here. I'll come back and explain these global level things in a second because I want to actually launch the cluster because it's going to take a minute to build. So we say add cluster. Ordinarily, at the global level, at clusters, you would see all of your clusters here. And the single Rancher server can manage hundreds of Kubernetes clusters. We're going to say add. We have our choice of provider. Do I want Amazon? Do I want Azure? Do I want to import a cluster that's already running from somewhere else? We don't care how you built it. If it's Kubernetes, we'll give you a command. You run it there. Boom. You can talk to it with Rancher. Do you want to provision compute nodes in a cloud provider and then install Kubernetes onto them? Just tell us how to talk to the cloud provider. Tell us what you want for nodes, and we'll take care of it for you. There's 4 cloud providers listed here. I'll show you in a second that we actually talked to a whole bunch more. For today, we're going to use the custom method. And the custom method is if one of these other methods doesn't work, then we will just give you a Docker run command to go and run on the cluster. Got all sorts of options here. You can pick your version of Kubernetes. You can pick your networking provider. You can tell it your cloud provider so that it knows how to provision load balancers. You can do all sorts of crazy cool stuff. We're going to leave all of this at the defaults and we're going to say next. Now, because it's a 1-node cluster, we're going to give it all 3 roles. But you can, for example, in a production environment, you probably want to have 3 nodes for etcd, 2 nodes for control plane, and then all of your worker nodes. They're going to be sized differently, and you want to make sure that if a workload spins out of control, it doesn't take out a node and take down etcd and take the rest of your cluster with it. But for today, we're going to live dangerously. You see that as I add and remove these, it changes that command down there at the bottom. That command is static for the cluster. So that means you can take this and you can put it into, let's run it first. You can take it and you can put it into Chef, Ansible, Puppet, Cloud Init, whatever you use to provision servers, Terraform, if you use something external. And now you can have, for example, an Amazon auto scaling group that you can scale up nodes on, and those nodes will automatically join the cluster. 1 node registered, and Rancher's going to go off and spend some time building this cluster. While it does that, I'll walk you through the global stuff here at the top. First thing, authentication. If you have an external authentication provider, please attach it here. And this will bring in all of your users and groups, and you can immediately start creating roles and assigning groups to roles and then assigning those to clusters, projects, pods. Like you can get super granular. So you get global, cluster, and project level. If you don't want to use these, then we're just using the local database now. You can still come over here under users and you can add additional users and give them roles and stuff like that here. A more advanced concept for Kubernetes is a pod security policy. PSPs dictate what pods are allowed to do on a cluster. So for example, you can have a pod security policy that says no cluster can run pods with containers that run as root, or everything has to use less than this number of resources. You can set these really cool global level directives and then apply them to all of your clusters. I'll say as well that the authentication thing, this isn't just about accessing Rancher. This is about accessing the clusters. Rancher becomes an authentication proxy. So you'll run kube control directly against Rancher to talk to one of the clusters that it manages. And if you don't have permission to talk to that cluster, you don't get to talk to it. Now, what you get with this is you can have clusters anywhere. You can deploy stuff in Google, in Amazon, in Azure, in your house, in your office, in DigitalOcean, and you don't have to worry about creating users and IAM policies and what happens if somebody leaves the organization, what cluster did they have access to. Everybody goes through Rancher, and if somebody leaves the organization, you disable their account in Active Directory and they lose access to all of their clusters. If somebody's role changes, you control everything in the same place that you control everything else. And that applies to every single cluster that Rancher manages. Rancher ships with an application catalog that I will touch on briefly in the cluster demo. They are curated applications that we ourselves use. So while we don't provide support for the applications, we do say that, if you launch this, it's probably not going to break your cluster. It's a great way to get those applications quickly deployed onto your clusters. If you want to use the entire stable or incubator Helm repositories, you can activate those here, and then you'll be able to deploy applications from there as well. If you have any third-party Helm repo, Elasticsearch, Artifactory, OpenFast, anybody who gives a Helm repo for deploying their stuff, you can add their repository here. It'll show up in this list down here, and you'll be able to deploy their stuff via the app catalog as well. When I deployed the cluster, I showed you that we had 4 things available there: EC2, Azure, DigitalOcean, and vSphere. These are for deploying compute instances onto which we install Kubernetes, and then we wire it back into the Rancher server. You'll see that there's others in here that you can enable. And if you have any external Docker machine driver, you can add it and talk to hosts that way. So if you have some other cloud provider that you deploy infrastructure on, then you can, as long as there's a Docker machine driver, you can bundle it up with Rancher and start scaling systems. Our cluster is alive. Now you see he's up here. So we have the cluster called training, and then we have 2 projects, default and system. Let's go look at the cluster. This gives you some really basic information about the state of the cluster. And in all honesty, this page isn't terribly useful. In Rancher 2.2, we ship advanced monitoring and metrics that are bundled with Prometheus and Grafana, and we have a ridiculous amount of information that shows up on this page. Graphs about everything from the cluster level to, the global level, the cluster level, project level, individual pod levels. You can see in real time what's going on everywhere in any of the clusters, and you can use all that information for capacity planning, for auto scaling, for stuff. So this is what it is now, and 2.2 is GA at the end of March, and this is going to become a lot more powerful. We give you a kube control shell here. So this is great for one-off kube control commands if you want to run some stuff. If you want to run kube control locally on your machine, we'll also give you a kube config that you can simply copy to clipboard and come paste over here. And that's what you saw me doing before. Like, I already had built a Rancher server. That's what we were doing all of the earlier Kubernetes stuff with. So you've got that flexibility. Or if you want to actually use the UI, let's come down and we'll jump into a project. Let's deploy something. We will deploy Superseb Rancher demo. And this is all going to go really fast because you've already seen all of this at the Kubernetes level. You're going to put it in the default namespace. Here's where we can control what is it? Is it a deployment? How many pods do we want? Let's launch 2. Is it a daemon set? Is it a stateful set? Is it a cron job or is it a regular job? Total flexibility right there. We're going to add a port here. We're going to say that it's cluster IP, so this will create the service for us. And here you can start adding environment variables. You can do node scheduling. You can set up your liveness and readiness checks. You can attach your storage. The person who was asking about that. So here you can add an ephemeral volume, which is just like a scratch space that gets attached to each pod. You can create a new PVC. You can attach an existing PVC. You can attach a directory from the node. You can also do secrets, config maps, certificates, and attach them as volumes. So here you have all these storage options. And if we were, for example, to add a new PVC, if we had a storage class, here's where we would specify which storage class to use and what to attach. Volume stuff in direct Kubernetes YAML is unpleasant, but volume stuff via the Rancher UI is nice. You can control how you want it to scale, rolling updates or whatnot, and then a whole range of advanced options as well. So we're just going to launch 2 of these, and we're going to say launch. And it's going to go, and it's going to do that. So you see we've got 2 of these containers creating. If I say get deploy, you'll see we have a deployment called Rancher Demo. It's everything that you already saw me do. We're just doing it via the UI. These guys are running. Jump over to service discovery, and you see that it created a service for us. Service of type cluster IP, there you go. That's taken care of. Oops. Let's throw an ingress up. I'm going to say add ingress, and we're going to call this Rancher Demo. It's in the default namespace. We're going to automatically generate XIP hostname. We give you the option to route stuff to a service, which is what we're going to do now, or you can also route stuff directly to a workload. And why you would choose one over the other, I generally expose stuff via services because that's the traditional way to do things. But that requires that the service exists, obviously, and that the port itself is exposed on the pod for the service to talk to and stuff like that. If you just have another port that's listening on the pod, you can actually route it directly to the workload, and Rancher will handle being the service for you. So in this case, we're going to route it to the Rancher demo service on port 8080. If we had an SSL certificate, or if we were wired up with Let's Encrypt, we could attach those here. And I'm not going to get into labels and annotations today. We're going to save that. And in a minute, it will generate an xip.io hostname. And if we click that, Ingress might not have been ready. Oh, I screwed something up. Okay. When I built the cluster, I was supposed to tell it. So this is actually an internal IP, and since it's a Vagrant cluster, I was supposed to tell it that it had a different external IP. So I didn't do that. Let's go back to our previous one, because it's actually going to be on that IP. And we have to change. All right, so this is worth noting. We got a 404. The reason we got a 404 is because the ingress is looking for a request on that host name, and that's not the host name that we're asking for. So we can fix this if we edit the ingress, and if we specify the host name, and if we change this to, let's just call it, what was our IP up there? 172. No, I do not want to enable Siri. Thank you very much. 172.22.101.111. And we'll save that. And I should have updated. That's interesting. Try that again. 172.22.101.111. That's my host name. Save. Man. All right. We're going to delete that. We're going to add this again. Specify host name. We're going to call this 1.1.111.xip.io. And we're going to delete that. Now, while I'm doing all of this, it's a little annoying because this is because I'm not working in the cluster environment where I normally work. So my standard demo workflow is not working. However, imagine how much longer that would have taken me to do if I was creating YAML and editing it and so on. That's up. We're waiting for an address to appear. It might already be, yeah, so it's not ready yet. Let's come over here and see what happens. Hey, there we go. So here's our Rancher demo, which has 2 containers, and you see that it's got 2 containers, and it happily tells us which one is serving the request as it load balances back and forth between them. Other stuff that exists within Rancher, here's where you would add persistent volumes. Very quickly say that I want sorry, that's where you would add persistent volume claims. At the cluster level under storage, here's where you would add persistent volumes. So if you wanted to have a persistent volume, you have a host of options here for what type of storage you want it to be, OpenEBS or Storage OS or whatever, capacity. And so if we chose, for example, Gluster, then it's going to ask us for information about where that volume is actually located. Once those volumes exist, they would then be available to create PVCs, or you can create them automatically during workloads. Catalog apps. These are the curated list of apps that I told you we use. And, well, we don't use all of them. Some of them are just here for demo purpose. So imagine that you have an application that you want to deploy. You want WordPress. So you come in here and you can set up some stuff, set up a password, set up a username, set up an email address. Do you want it to have a persistent volume? Tell it what storage class to use. You answer some questions. And this creates that, and it creates all of these YAML charts, well, YAML manifests for everything. Like, you're never going to sit down and create this by hand. And when you say launch, it's going to go out and build you a WordPress application, and it will be running. So you see it's starting to build the database itself, which is already active, and it's going to build the WordPress, and it's going to wire it all together. That's the value of using catalog apps. If you are in an organization that builds applications for consumption by other people or business units within your organization, you can bundle those apps as catalogs, and you can give other teams the ability to deploy those apps as they see fit. You might have an approved version of Redis, or an approved version of MySQL, or an approved version of something. And rather than giving people the ability to just deploy stuff willy-nilly, you say, look, here's our Redis template. And they just say, I need a Redis cluster. Boom, they've got one. Other stuff that you can control quickly within Rancher, secrets. So this securely stores secret data, and you can attach this to your workloads. So imagine API keys, database passwords, things that you don't want to actually have in the workload configuration. SSL certificates, config maps, which are an advanced thing that we'll cover in the advanced Rancher introduction. You can attach to arbitrary backend logging systems to export container information off of your system for analysis by Splunk, or you can build Kibana dashboards, or whatever you want to do. And if you use an external registry, you would configure that here. So imagine Quay or GitLab or anything else, Artifactory, Nexus, anything, Harbor, all of that. You can configure the credentials here and then use those when you deploy the workloads. And then you can attach external repositories here and start to build your own pipeline stuff. This is if you don't already have an external CI/CD system. If you do, then you just would attach that via kube control directly or via the Rancher CLI. So under workloads, we've now got WordPress running. It created an ingress for us, and that's not going to work because of the IP thing. So the last thing I'll talk about before we wrap this up with questions is that there's a Rancher CLI utility. Now, you saw me doing all this stuff with kube control, and anything that you can do with kube control, you can do to spin up your workloads. It's your choice whether you want to do it via the command line, whether you want to do it via the UI. But when you get to where you have external systems building and launching workloads, CI/CD systems or other automation systems, you might, for example, push code to a development branch. Your CI/CD system checks it out, runs a bunch of tests, and then needs to provision a cluster and deploy the code onto the cluster to use to target it for more advanced tests with maybe Selenium or user acceptance testing or something. And then it needs to tear that back down. Well, you can't provision clusters with kube control, but you can provision them with Rancher. So where kube control stops and Rancher begins, for example, cluster provisioning or any of the other Rancher specific stuff that you've seen me do, you can do that, not all of it, but most of it with the CLI. The CLI will also proxy kube control. So now back to our CI/CD example, instead of having our CI/CD system use the Rancher CLI to provision some hosts and then kube control to talk to them, you just use the Rancher CLI to provision those hosts, and then you use the Rancher CLI to talk to stuff. So literally it's Rancher, kube control, and then whatever the rest of the kube control command is. Extremely powerful way to get API access for everything that you see going on here. That's actually the last thing I'll show. Everything I'm doing in the UI is talking to the API. We're an API-driven application. It's all API. So you can click on the API and come in here and click yourself around and find a whole bunch of stuff, which is terrifying and confusing. But if you want to find something specific, at every single object on the hamburger menu, you will see View an API. If you click that, it will take you directly to the API object. And here you can say, what are you able to do with it? You want to pause it? You want to roll it back? Do you want to delete it? If you select one of these things, we'll give you the curl command. We'll give you what the HTTP request is. And if we send that request, we'll give you the HTTP response. And if I jump out here, you'll see that that thing that I was talking to a moment ago is gone. So it's real-time API access that will allow you to translate commands into stuff that you want to do with your application. I actually deleted the thing that I wanted to show you, so I'll use the WordPress thing here. Within Rancher, you have full access to the YAML, and not just to view it, but to edit it as well. So we can change images, we wouldn't do it here because this is a catalog app, but any workload that you deploy, you can come in here and take the YAML and do copy to clipboard, edit it, change it, do whatever you want with it. Any way you want to interact with your cluster, you can. I will stop there because, as usual, we are over time, but I imagine that there are questions.
Awesome, Adrian. Cool. Great stuff. Okay, let's get to the questions. Here's the first one. Let's say a customer has deployed a Kubernetes cluster already. Is it possible to have Rancher manage those existing Kubernetes clusters?
Absolutely. So the way that you would do that is out here, when you say add cluster, you would say import an existing cluster. And we'll call this customer. And when we say create, it's going to give you a kube control command to go and run. Obviously, this one, this is a private IP address, but you would go and run this against that cluster, and it will create a Rancher namespace and then deploy the Rancher agent into it, and the cluster would then show up over here, and you would be able to do everything that you just saw me do.
Awesome. Cool. Thank you, sir. Okay, here's the next one. How can I deploy a workload that pulls a Docker image from an internal Docker repository that's not exposed to the internet?
Well, I'm assuming that your cluster is in the same network space as your repository, because if it's not, then this is never going to work. But let's just assume that it is. We're going to come over here and so I'm in my default project. I'm going to come to registries and I'm going to add a registry, and we're going to call this internal, and it's going to be custom. And where is it? It's registry.internal.company.int, whatever. This represents the name, the DNS name for your internal registry. And I'm going to give my login credentials, and I'm going to say save. Now that registry is active. So when I come over here to workloads and I say deploy, then I would say registry.company.int, whatever your DNS name is, /whatever, /image, :tag. That's it.
Sweet. Okay, awesome. Here's the next one. Does Rancher have any plans of supporting Knative feature in the future?
It's one of those
broad
questions. So Knative is a serverless framework, and you can run Knative within a Kubernetes cluster. Since Rancher manages Kubernetes clusters, you can run Knative inside of any Kubernetes cluster that Rancher manages. The two they're two totally different things. It's like putting a box in the trunk of your car. Like, your car doesn't have any special superpowers, the box doesn't have any special superpowers, but you can use one with the other just fine.
Okay, amazing. All right, here's the next one. Um, does Rancher have an integration with Doc for Mac? Oh, with Docker for Mac.
No, you cannot run Rancher inside of Docker for Mac. And the reason for that is because Docker for Mac it's not native. It's a virtual machine. So let me correct this. You may be able to run Rancher inside of it because ultimately it is just Docker, but it's inside of a virtual machine. So nothing is going to work. No ingresses are going to work because the Rancher server doesn't know that it's inside of a virtual machine. It just assumes that it's on a machine that's directly connected to something. So therefore, it's not much use if you can't talk to it. And since clusters that it manages have to reach back into it, it's just going to be totally hobbled. It won't be able to do anything. What you can do on Mac, so I'm on a Mac right now. If you want to play with this, you can do everything with Vagrant. So this is our Rodeo repository, open source, grab it, bring it down, and just run Vagrant up. It'll give you I'll give you two nodes. You can put Rancher server on one, and you can put, whatever, make a one node cluster on the other one. I recommend you use the Rodeo version because then you can actually run all of the commands. But if you are a professional system administrator who aspires to epic levels of automation, then you can use the Rancher Quick Start. And the Rancher Quick Start, when you run Vagrant up, will not only provision the nodes, it will also install Rancher, and it will also build you a cluster. So literally you run Vagrant up, and in like 6 minutes, you'll be able to log into a Rancher server, and you will already have a cluster there that you can start deploying workloads to. So if your objective is to start using Rancher, that's an even faster way to go.
Oh, sweet. Awesome, thank you. Okay, here's the next one. It's actually a request that when we send out the recording and the slides, if we could also send your alias file of commands. Would that be possible?
So no, and I'll tell you why. Because my alias commands are actually this guy. So if you just go to GitHub and look for kube control aliases, this guy has the mega list of aliases. And I pulled out stuff from here that's just the stuff that I use, but check this out. This is madness. So go here and use the source. He works for Google.
Awesomeness. That's the last question actually.
Oh my gosh.
I know this never happens. So if there's anything else you want to show, or we can just talk.
Yeah. So in closing then, if you want to learn more about microservices and building distributed systems within Kubernetes, this is a good start. This dude was the director of engineering at Azure. He might still be the director of engineering at Azure. I'm not sure. I haven't actually read this book. I looked it up, found it on Amazon. The reviews are meh. But generally, people agree that this is a good introduction into distributed system design. So if you're just getting into microservices, this is a good place to start. Also, as you're no doubt aware, there's literally a bajillion web pages out there on Kubernetes filled with information. A lot of it's confusing. If you get stuck, I recommend that you follow a strategy that I learned when I was in the 5th grade, which is if you don't understand what you're reading, just read it again. If you still don't understand it, read it again. And your brain will eventually grab hold of more and more of it. And then one of the times that you read it, you'll be like, oh, wait, that kind of makes a little bit of sense. Just take it slow, stay patient. Remember that this is all about learning, and don't freak out at the volume of information that is available at any given time. Kubernetes documentation is also really good, kubernetes.io. Rancher's documentation is also very good. We work hard to keep that up to date, so that's at rancher.com. And if you are interested, if you enjoyed this training, if you like the way that I talk about things, I create content for Rancher. I also talk about random stuff. So please feel free to follow me on Twitter. I am also on LinkedIn. You can actually go to LinkedIn, and I'm the main Adrian Goins. But if you search for Adrian Goins, you'll also see that there's a dude that works for Aetna. He looks different than I do. I'm not him. So, um, and you can find me on the Rancher user Slack as Adrian. So if you find me there, if you have questions, I'll do my best to help you out. We already did the demo. So Matthew, go ahead and take it back and let's wrap it up.
All right, fantastic, Adrian. Okay, can you see the, oops, I think I might have just ended, yeah, the Slack slide?
I can see the Slack slide, yeah.
All right, terrific. So everybody, just a reminder in case you missed it, this is the URL to get to the user Slack, slack.rancher.io, free to sign up. Hundreds of people on there every day, thousands of members. Please join, stay connected. The channel for this training was training-0207, so you can get to know each other there. And thank you very much for continued training, more education. We've just launched this Kubernetes Masterclass series. Adrian has one of these sessions coming up in April, but we have sessions every single week, lots of different stuff. Really, really cool. I think we had over 1,000 registrants for the first one just a couple days ago, and hundreds of attendees. So it's awesome. Tons of great discussion. And as we said at the beginning, all this information is recorded, so you will get the video recording, the slides, and the Q&A in your inbox. And that's it, everybody. Have a great week. Thanks so much for your participation.
Thanks for coming. See y'all later.